You're listening to Off to Market with Scott Farley and Hamish Chadwick.
Hi, I'm Hamish.
And I'm Scott.
And today we are going to be talking about some interesting stuff. Scott is going to lead us in with prototyping. Scott?
Go ahead.
What do you reckon?
Fire away. So we did touch on prototyping in our engineering podcast, but it was a bit of an overview of it. But it is quite an important part of the development process, and also can be very important in your, well, primarily it's used for testing things. So your theories become physical, and you can test things with prototypes. You do CAD, you can do a fair amount of testing on CAD. Quite often I can go straight from CAD to a final prototype, and there's only, usually either no modifications to make or very minor modifications, but you're dealing with something on a screen that's visual only, and when you get something in your hand it's entirely different. You look at it and feel it a different way, and you know how it all fits together and locks together, all the little tactile things that you need to have right. But the other side of prototyping is, and it's something we do a lot more than someone's got a bugle outside on their horn.
Yes, for the benefit of the listener, there's someone with a interesting car horn.
Dukes of Hazzard are down
That's
the road.
right, yeah.
So you can use it actually to great benefit in downstream stuff. So if you would put in a bit more effort into the prototype, you can actually use that prototype for things like marketing and demonstrations and raising funds, getting orders, all that sort of stuff, which can be really, really crucial.
So prototyping then is not just for you and the client to determine whether there needs to be any changes. It can actually, well, I suppose by that point you're not really wanting to really push to find changes, but you then use that as a platform to market. So it is quite vital. And so what are the costs involved? I'm sort of jumping into this, but what are the costs involved typically for prototyping? Obviously, what is it you're designing? But to produce one item sounds quite expensive. Is that the case normally?
Look, it's a really relatively slow process, so there is costs involved. There are lots of different levels of prototypes, so you can start off with we've got polymer printers that basically take an LED screen and run off apart fairly fast. So that's relatively cheap. A few $100s you can get a part made and get a feel for how it sits in your hand. It's usually I do that for a form model, just see how the ergonomics is working, how it fits in your hand, how it feels to touch, lift, all the rest of it. So that might be the first stage. I mean, it goes right back. Usually the stuff I'm doing is fairly unique, so there's nothing really to benchmark off. You can't just go and buy a product off the shelf and go, well, this one works this way, I'm going to do it that way. Some of the stuff we're doing, for example, we did a twin cam, the first twin cam ratchet for a dog collar, and my first prototype for that was a piece of C-channel aluminium with a dowel through it and a piece of aluminium that I'd cut into a shape of a cam, and I put two in a little jig, put my webbing in there and tested it, and it worked. So that can be as simple. I'd never show the client that. It's totally ridiculous. It looks awful, but in my mind, I can sort of have a theory and then test it and then develop it up from there. So that can be the simplest. I call it a proof of principle jig, and that's still a prototype. It's a physical form of what you're thinking, and it's a way of testing the base principles. I think I talked about a teat. That product ended up changing the world of packaging on a worldwide basis, and that started off. It was a self-evacuating valve, which basically took the air out of a bottle once you've packed it or once you've drunk a certain portion of it. So the way I tested that was with a teat from the chemist, and it was a $2 teat in a collapsible bottle, and instantly I knew the theory would work. So and that developed into a product that you see every time you open a package nowadays. It's a perishable product. The water or the orange juice or milk or whatever is filled right to the top. There's no gap. There used to be like an inch gap, and that saves 3 or 4 days, or extends the life of the product on the shelf for 3 or 4 days, and it saves billions of litres of waste all around the world. So it's a really cool little product. It made no money, but it was a nice social offshoot of that little thing that started off with a teat in an expandable bottle. So that's something a little grew big. But anyway, so you go sort of from that proof of principle prototype, which is a physical way of testing a theory, and you can work your way through the concept development stage into the CAD, and then once you have the CAD, you can go and print these products with 3D printing. It's quite a common term these days, but it's been around for a long, long time. And there's different forms of 3D printing. You can print polymers that are offset by UV light, or you can powders that are sintered by lasers. There's all different types. You've even got metal powders that can be sintered by lasers and give you really strong parts that can be tested, thoroughly. Or you can mill things. So all those processes are additive. So you're taking a powder or a fluid and you're adding some sort of heating or curing process, and you're creating layers of addition. So you're adding, like a printer on a paper, you put a layer of ink down, you're just putting a layer of polymer down, and then you're putting another layer of polymer on that, another layer of polymer on that, until you've built up this product. Obviously that takes a long time to do, and some of these processes are all-night processes, and that's why the cost is fairly high, because there's still a lot of time involved in these things. They can be used in manufacturing, but they don't suit every product. Obviously they take time, whereas an injection molded mass manufactured part is very quick to produce. You don't really want to be producing a kettle that takes 5 days to print each one, you know what I mean? So they've all got their use. Really, really handy if you've got things that change all the time and are really complex, like airboxes on race cars. They are really complex, they're always evolving, and they've got lots of internal parts. If you were to make an injection molded tool for each one of those components and add those 5 components together, you're looking at hundreds of thousands of dollars and months worth of work. Whereas if you just print all the internal and external parts, you can test one, you can do it overnight, test it, and it doesn't work, you change it and test it again, and the materials are strong enough to cope with those sort of heats and things. And then you go right up to the subtractive manufacturing, prototyping, where you're taking materials that may be used in manufacture or in a final product, and you're just milling away the material and leaving yourself with a product. So I use that a lot because those sort of processes, and they've advanced a lot in recent years with 5-axis CNC mills, where they basically can put a block of material in a holder and set the cutting paths off, and it just builds this thing, all automatic change tools and all the rest of it. So far quicker than it used to be when it was all done manually by hand with change parts, and very hard to jig. These days you put it in one chuck, you set it going, and it just makes the part for you. Really handy. You end up with a very, very accurate part made from materials that might be very similar to what you might use in the end result. They won't be exactly the same, because there's only a certain amount of materials that are made in block form. They're extruded in block form, whereas if you go and get injection molded parts, you'll be finding a very specific plastic for that application. Okay. So you'll take a family, maybe a glass filled nylon, you can make a product that's quite nice and strong, handle being used and tested. But you might, in the injection molded final part, have a very specific type of that nylon to suit the application of the product. It's a pool filter, you might use a product that's very good with UV, good against chemicals and that sort of thing. So proof of principle obviously is just proving your theories with something rough and ready. The printed versions, you can use them to present, you can use them for form and fit and all that sort of thing, ergonomics and everything like that. But what I find really handy with the manufactured versions, the milled versions, is that you can actually make them look and react and feel and be tested just like a final product. We just finished doing the first rotating rod holder. So in fishing, you have a rod holder where you put your fishing rod into it in the side of the boat. It's fixed in a certain angle, and you just run your line out of that fishing rod. You've got no choice as to where that angle of that rod is. So it's handy to be able to move it, to be able to change the angle of your rod so that you can change the width of your spread on your trolling lines, all that sort of business. There's lots of benefits for having it. You can pull it right in when you're underway so that the rods don't bounce out. All these huge benefits. But we did that, and we milled a stainless steel version, and it was almost exactly the same materials as used in the actual final product. So we could actually go out there and test it. Because one of the things it had to do was be strong. So we could do all the FEA testing on CAD, but to actually physically go and test it and make sure it's going to cope with the rigours of fishing, which is quite a lot of strain and pressure on these things, we could go and do that before we went to manufacture. So it's a really good way of, and not only that, we use them for videos, demonstration videos, campaigns, getting investors involved. One thing that's become incredibly obvious to me over the years is how few people can actually make visual leaps between, like if I put a concept on a page, my chances of getting an investor involved looking at a 2D sketch, even though it looks to me like I've explained everything in the product, the chances of getting an investor involved at that point are almost zero. People just can't make the leap between 2D and a physical part. If you go to any sort of prototype and they can hold and touch and feel and get a feel for how it works, you've got an infinitely higher chance of getting an investor involved or getting any sort of interest in partnerships when you have that product there. If you go to the next level and you have a product that looks like it's been manufactured and it tugs on all the emotional ties, that, you know, the colour, the finish, all these things that come into it, all the way things react and tactile, things like weight and snap fits and all the rest of it. If you can tap into those emotional ties, you've got a very good chance of getting people hooked emotionally on that product, and then maybe getting investment or whatever, or an order off it. So it's hugely beneficial. A video, I mean, this may be where you step in. When you want marketing material, I mean, how useful would it be to have a video showing the actual manufactured part from your side of things?
Well, interesting concept, because obviously the programs that you use, you can produce 3D models. There's nothing stopping people from using that in a video. I mean, if you're videoing something, you can't touch it anyway, so you can, the way some of these programs work now, you can build a 3D model and make that look quite realistic, you know, with lighting. As long as the lighting's good in the video, you can make something look real, as real as you can, without producing the product and then filming the actual product. The trick is just the tangibility, so it's just the believability at that point. But I think that's, just to touch on that subject before that you were talking about, is it's much easier to sell to someone with a tangible product that they can touch, because they haven't got the emotional or the intellectual investment that other people involved in the product, other people have been involved in the project for months, maybe even years, you know, because everyone has a clear picture in their mind as to how they want it to work, and then you go and sit down in front of someone and you just want them to get it within, you know, 2-3 minutes, because obviously, you know, these people review, if they're an investor, they'll want to quickly review it, make their own mind up as to whether it's got any future. So obviously at that point, having something that they can hold on to, if that's possible, is vital, because it means they can start to create their own mental picture, rather than you just
as well as other technical issues solved. I think the problem with animations, you're right, they're very, these days they're so...
They can be very detailed.
So detailed, and we use them where we can't describe something. Like, you know, if you've got a subatomic situation, we've got a thing that, you know, sterilises a product. In a subatomic level, it's doing this, and visually, this guy could do it. He's great with the animations, and he made it look like, you know, amazing, really, really accurate. But I think people are so used to seeing how good animations can be that they think there's a bit of foolery in it. Like, is it actually going to work that way? You know, for the physical product, you can actually physically tell that technical barrier has been ticked off. Okay.
Well, but again, I think that comes down to
the level of risk goes down.
Yeah, I appreciate that point too, where if you present just simply a video, I mean, the video could be of an actual product a physical product, but even if it's a 3D model that's been executed very well, the believability side of it and whether someone thinks it's going to work or not comes down to, I think, a number of factors if you're getting in front of investors, and that is, what's the cost of the product? You know, where's it supposed to sit on the shelf, literally, like its positioning? What's the market need? Like, are you having to create a need, or is this a need that people are just going to instantly go, oh my god, I need one of those? I mean, that's rarely the case. I think every product that is put out there, even ones that are unique, require a certain sales approach. Nothing sells itself, essentially, unless it's the cure for cancer or something like that. I mean, not, you know, to use a silly example, but so I think, to answer the question, video is vital, but I really, if you can get a very good 3D model, I think that would just be as effective as a physical model videoing it. However, if you can build something and put it in front of someone, sure. I think tangibility is great, because it is actual proof of concept, isn't it?
So, I mean, the great thing about having the physical model, you video it, people don't actually see it's a physical model, they actually see it work, unless you're doing some sort of film. Well,
especially if you can film it in use, for whatever it is.
You film it in use, and so that's the first stage. But then backing that up, they go, okay, that's sort of the hook. That's to get in the door. Then you get the meeting at the boardroom level, and you actually turn up with the actual product, and you hand it around. That can really push you to the next level. Yeah, rather than animation, you're still turning up with the same animation you had before, and well, you know, there's still a lot of technical barriers that haven't been proven off. So it can be really, really, in my experience, been really, really useful. We actually, I used to offer it to my clients. We just started a company called APS, Advanced Prototyping Services, where the public can use that same service where we mill parts for people if they have the CAD.
Yep.
But yeah, we don't push it very hard. I'm not very good at marketing, so it's my first level of marketing right there.
Do you need a prototype?
But you know, it does create a lot of work for me, so I sort of I don't push it hard, but it is an option
Yep.
there. And as I said, the technology has improved so much in recent years that it allows it. Whereas previously, it was still a pain in the bum to do a 3D mill part because it was all manual, and where that used to always fall down with accuracy is you have to do two sides of it, top and bottom. So you do the top, beautiful, turn around and you get the datum point wrong, so you start from the wrong point, and the bottom's a little bit different to the top. So that's where the accuracy used to be an issue, and you were sort of relying on the user or the human error of the operator of the mill
Yep.
to get it right. Whereas nowadays you put a block in a single chuck and it moves all over the place, so it gets undercuts and bottom, top and everything, so it doesn't need that rejigging. So generally it's a very, very accurate part as well.
Okay.
Yeah.
So I think the takeaway from this episode is essentially, yes, a physical prototype, if you can get it, is better than not having one. It's also a good thing to have as part of your sales process. That's also, even though there's a cost involved in doing it, I think it's what Scott is saying is it's a vital ingredient if you're going to see investors.
Agreed.
You've been listening to Off to Market with Scott Farley and Hamish Chadwick.